Today we will apply our knowledge of roots and exponents to solve equations, starting with solving equations that contain our radical symbol, okay, most of which we've worked with are square roots, but this index can change. Okay? We can have multiple different indexes while solving these equations. While solving, it involves getting the variable alone, using inverse operations, and checking your work and your solutions. We need to check our solutions, especially today. So first example, okay, our end goal is to solve for x. Okay, we want to get x alone. Okay, we need to follow our inverse order of operations. So if I'm thinking my order of operations, PEMDAS, okay, when I'm solving, I start at the back and go to the front. Okay, my end goal is to get x, but before I do that, I have to isolate this root symbol. I have to get that root symbol alone. Then I can get rid of it using its inverse of an exponent. Okay, so first I have to get rid of this plus 7 by subtracting 7 from both sides. I now have 2 cube roots of x minus 3 equals 4. I almost have that root symbol alone. I got rid of the 7, but I have this 2 in front. Okay, it's being multiplied by the cube root of x minus 3. So to undo multiply, I have to divide both sides by 2. That cancels on the left. I now have the cube root of x minus 3 equals 2. If we think back to when we solved by square root earlier in the year, okay, square root and squared were inverses. They canceled because the index on that square root was a 2. Okay, well, the inverse of cube root is going to be to cube both sides. On the left side, cube root and cubed cancels, leaving me with the radicand, or what's underneath the root symbol. 2 to the third power is 8. And my last step is to add 3 to both sides. And I get my solution, x equals 11. Okay. Now, our last thing to do is to check for extraneous solutions. Okay. Well, if I look back to my original problem, if I put 11 in for x, okay, 2 cube root of 11 minus 3 plus 7, that has to equal 11. Okay, well, 11 minus 3 is 8, so 2 times the cube root of 8 plus 7. Cube root of 8 is 2. 2 times 2 is 4, plus 7 equals 11. So I checked that solution, and it works out. You can plug that into a calculator as well, okay? And I can show you that moving forward on any assignments that you have, okay? But we always want to check for extraneous solutions. Example 2, okay? This time, both sides have a cube root, okay? I have nothing outside of those cube root symbols, okay? So I got the cube root symbol alone. I can now cube the entire problem. Okay, when I do that, my cube roots and cubes cancel, leaving me with 2x plus 3 equals x minus 1. And I solve for x. I'm going to move the x's to the left. I'm going to move the constants to the right, leaving me with x equals -4. Okay, if I quick look at the top, okay, 2 times -4 is -8, plus 3 is -5. Okay, on the right side, -4 minus 1 is -5, so that checks out. Okay, I checked my first extraneous solutions. Okay, next one, there's a little caution symbol here. We're probably going to have some extraneous solutions here. Okay, so on one side of my equal sign, there are no operations outside of the radical. Okay, so I'm allowed to take the square root right away of both sides, not square root, I'm sorry, squared. I'm allowed to square both sides right away to get rid of this radical symbol. Okay, but if I do it to the left side, the right side, okay, I have to do it to the left side. Okay, on the right, the square root and squared cancels. So I have just the radicand, 7x plus 15. On the left side, I have a squared binomial. X plus 1 squared means x plus 1 times itself, x plus 1. I have the multiplication of two binomials. I'm going to multiply, FOIL, double distribute, however you learn that. Okay, that's what we're going to do. So I take x times x, I get x squared plus 1x plus another x is plus 2x plus 1 equals 7x plus 15. Okay, I'm solving for x. Okay, the degree of this equation is 2. Okay, this is a quadratic. Okay, in order to solve a quadratic, I will have to factor it. Okay, but in order to factor it, I have to get it equal to 0. Okay, so I need to get all terms onto one side of the equal sign and solve. So again, since it's a quadratic, a degree 2, I'm going to move everything to one side of the equal sign and use my factor to solve method. Okay, again, on the right side, I now have 0, which is what I want. On the left side, x squared minus 5x minus 14. Okay, I'm going to factor to solve. Okay, this is a super easy quadratic. Leading coefficient is 1. So I know that in my two binomials, my first numbers are x and x. My second numbers are factors of 14, where one of them is negative. Okay, it's a negative 14, so one of them has to be negative. So their difference, the difference of those two factors has to be 5. Well, the difference of 1 and 14 is 13. The other two factors of 14 are 7 and 2. Okay, negative 7 plus 2 is negative 5, and that works out. Those are my two factors. Okay, the last step would be to set equal to 0 and solve. So x equals 7, and x plus 2 equals 0, so x equals -2. I'm going to let you plug these in the calculator, so pause the video quick and see if there are any extraneous solutions. Okay, I'm assuming you have paused and plugged these in the calculator to see if they are equal on both sides. Okay, x equals 7 balances the equation, but x minus 2 is an extraneous solution. So x equals 7 is the only solution that makes both sides equal.